When considering substituting Japanese wire for American wire gauge number 12 American wire gauge with thermoplastic high heat nylon insulation, it's crucial to understand the relevant electrical standards and regulations in both countries. It is important to note that electrical standards and regulations vary significantly around the world. Firstly, in Japan, the Japanese Industrial Standards, or JIS, is a widely used standard. Secondly, the International Electrotechnical Commission, or IC, standards are also relevant. A voltage carrying tester, or VCT, is used to measure electrical leakage and resistance. In the United States, the National Electrical Code, or NEC, is the primary standard, along with Underwriters Laboratories, or UL, which provides safety certifications. Thermoplastic high heat nylon, or THHN, refers to a specific type of insulation. When assessing cable compatibility, the Japanese standard JISC 3306 for insulated wires and cables is important. American wire gauge indicates the wire size or diameter. A voltage carrying tester measures electrical leakage and resistance. A cable comparison shows that a 12 American wire gauge wire is approximately equivalent to a 2.6 mm² wire under the JISC 3306 standard. Both are typically rated for 600 volts and use stranded copper as the conductor material. A suitable insulation material could be thermoplastic vulcanized rubber, or TPV. The Japanese thermoplastic vulcanized rubber insulation is similar to the US thermoplastic vulcanized rubber insulation and can be considered a suitable substitute for the thermoplastic vulcanized rubber insulation required by the National Electrical Code. Consider the amperage. Ensure that the Japanese cable is rated for the same amperage as the US American wire gauge cable, which is 20 amps for 12 American wire gauge. Verify that the Japanese cable is rated for the same voltage as the US American wire gauge cable, which is 120 volts in this instance. Always follow local electrical wiring practices and obtain the necessary permits from the Japanese authorities. For further support, consult the Japanese Electrotechnical Committee at their website. Contact a local electrician in Japan for guidance and installation support. The U.S. Embassy in Japan may also have resources or contacts for electrical engineers. Based on the information available, it is likely that the Japanese cable with the following specifications could be a suitable substitute for the US number 12 American wire gauge with thermoplastic vulcanized rubber insulation. Firstly, it is a JISC 3306 2.6 mm² cable. Secondly, it is rated for 600 volts. Thirdly, it uses thermoplastic vulcanized rubber insulation. However, it is crucial to consult with a licensed electrician in Japan to verify the compatibility and ensure that the installation meets local codes and safety standards. When looking at specific requirements such as the need for number 12 American wire gauge with thermoplastic high heat nylon rated insulation, several factors must be carefully considered when attempting to find a compatible substitute in Japan. Firstly, understand the American wire gauge standard. American wire gauge is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The American wire gauge number is inversely proportional to the wire's diameter. This means that as the American wire gauge number increases, the wire diameter decreases. A number 12 American wire gauge wire has a specific diameter which dictates its current carrying capacity and resistance. Secondly, analyze thermoplastic high heat nylon insulation. Thermoplastic high heat nylon is a type of insulation commonly used in building wire because of its resistance to heat, moisture, and abrasion. The thermoplastic high heat nylon rating indicates that the wire can operate safely at temperatures up to 90 degrees Celsius in dry locations and up to 75 degrees Celsius in wet locations. It also provides a layer of protection against mechanical damage during installation and use. Thirdly, research Japanese Industrial Standards equivalence. The Japanese Industrial Standards System defines standards for various industrial and technological products, including electrical wires and cables. It is essential to find the Japanese industrial standards designation that corresponds to the properties and performance of number 12 American wire gauge or thermoplastic high-heat nylon insulation. Japanese industrial standard C3307 is often referenced for general-purpose polyvinyl chloride insulated wires. However, direct equivalency to thermoplastic high-heat nylon may not exist, and a combination of standards may need to be considered. Fourthly, compare wire sizes. Since American wire gauge is not a standard used in Japan, the wire size will be specified in metric units, typically square millimeters. A number 12 American wire gauge wire is approximately equivalent to a 2.5 mm diameter wire, or about 3.31 mm squared in cross-sectional area. It is crucial to select a Japanese wire with a similar cross-sectional area to ensure it has a comparable current carrying capacity. Fifthly, evaluate insulation materials. Identify the insulation material used in the Japanese wire and compare its properties with thermoplastic high-heat nylon. Key considerations include temperature rating, resistance to moisture, abrasion resistance, and compliance with Japanese electrical codes. Polyvinyl chloride is a common insulation material in Japan, but its temperature rating may differ from thermoplastic high-heat nylon. High-performance options like cross-linked polyethylene or other advanced polymers might offer comparable or superior performance. Sixthly, check voltage and current ratings. Ensure that the Japanese wire has voltage and current ratings that meet or exceed the requirements of the intended application. In the United States, a number 12 American wire gauge wire is typically rated for 20 amps in a 120 volt circuit. The Japanese wire must meet or exceed these ratings to ensure safe and reliable operation. Seventhly, confirm compliance with Japanese electrical codes. All electrical installations in Japan must comply with local electrical codes and regulations. These codes dictate the types of wires and cables that can be used in different applications, as well as installation methods and safety requirements. Consult with a licensed electrician in Japan to ensure that the selected wire meets all applicable code requirements. Eighthly, obtain certifications and approvals. Look for Japanese industrial standards or other certifications that indicate the wire has been tested and approved for use in electrical applications. These certifications provide assurance that the wire meets established performance and safety standards. Ninthly, consider the application environment. The specific conditions of the installation environment, such as temperature, humidity, exposure to chemicals, and mechanical stress, should be taken into account when selecting a substitute wire. Choose a wire with insulation and other properties that are suitable for the intended environment. Tenthly, consult with experts. Given the complexity of electrical standards and regulations, it is advisable to consult with electrical engineers, electricians, and other experts in both the United States and Japan. They can provide valuable insights and guidance to ensure that the selected wire is compatible and safe for the intended application. 11thly, document the decision-making process. Keep a record of all research, evaluations, and consultations conducted during the wire selection process. This documentation can be helpful for demonstrating compliance with codes and standards, as well as for troubleshooting any issues that may arise in the future. 12thly, perform testing and verification. Before putting the selected wire into service, it is essential to perform thorough testing and verification to ensure that it meets all performance and safety requirements. This may include testing for voltage drop, insulation resistance, current carrying capacity, and temperature rise. 13thly, be aware of color coding differences. US and Japanese wiring have different color codes. Ensure these are properly translated and followed when connecting the replacement wiring. 14thly, temperature considerations. Japanese building codes may have different ambient temperature assumptions that factor into their wire ampacity and selection. 15th, ground wire considerations. The ground wire requirements and standards might differ. In summary, substituting Japanese wire for American wire gauge number 12 with thermoplastic high-heat nylon insulation requires careful consideration of wire size, insulation material, voltage and current ratings, compliance with electrical codes, certifications, application environment, and expert consultations. By following these steps, it is possible to identify a suitable substitute that meets the requirements of the intended application and ensures safe and reliable operation. Always prioritize safety and compliance with applicable codes and standards. When dealing with electrical wiring, especially in an international context, it's essential to have a comprehensive understanding of the standards, regulations, and best practices involved. Here's a more detailed explanation of several key aspects to consider. Firstly, understanding ampacity. Ampacity refers to the current carrying capacity of a wire, which is the maximum amount of electrical current that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a wire depends on several factors, including its size, material, insulation type, and the ambient temperature. Number 12 American wire gauge wire with thermoplastic high-heat nylon insulation typically has an ampacity of 20 amps in accordance with the National Electrical Code Table 310.15 B16 for copper conductors at 30 degrees Celsius ambient temperature. It's crucial to select a Japanese wire with an equivalent or higher ampacity to ensure it can safely carry the intended load. Secondly, insulation temperature rating. The insulation temperature rating indicates the maximum temperature at which the wire insulation can operate without degrading or melting. Thermoplastic high-heat nylon insulation is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. When selecting a Japanese wire, ensure that its insulation temperature rating meets or exceeds these values to maintain safety and reliability. Japanese industrial standards like JISC 3307 specify temperature ratings for polyvinyl chloride insulated wires, which may vary depending on the specific grade and application. Thirdly, voltage drop considerations. Voltage drop refers to the reduction in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it's essential to select a wire size that is appropriate for the length of the circuit and the load it will carry. The National Electrical Code provides guidelines for calculating voltage drop and selecting wire sizes accordingly. When substituting Japanese wire for American wire gauge wire, ensure that the selected wire has a similar or lower resistance per unit length to maintain acceptable voltage drop levels. Fourthly, grounding requirements. Grounding is an essential safety measure that helps to protect people and equipment from electrical shock. Grounding systems provide a low impedance path for fault currents to flow back to the source, causing overcurrent protection devices to trip and energize the circuit. The National Electrical Code specifies detailed requirements for grounding systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures. When installing electrical wiring in Japan, it's essential to comply with Japanese grounding requirements, which may differ from those in the United States. Fifthly, conduit and cable tray systems. Conduit and cable tray systems are used to protect and support electrical wires and cables. Conduit systems consist of rigid or flexible metal or plastic tubes that enclose the wires, while cable tray systems consist of open frameworks that support the cables. The National Electrical Code specifies requirements for the installation of conduit and cable tray systems, including the types of materials that can be used, the methods for supporting the systems, and the spacing between supports. When installing electrical wiring in Japan, it's essential to comply with Japanese requirements for conduit and cable tray systems, which may differ from those in the United States. Sixthly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to trip and energize the circuit when the current exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. The National Electrical Code specifies requirements for the selection and installation of overcurrent protection devices, including the ampacity rating of the devices, the interrupting rating, and the coordination with the wiring system. When installing electrical wiring in Japan, it's essential to comply with Japanese requirements for overcurrent protection, which may differ from those in the United States. Seventhly, wiring methods and installation practices. The National Electrical Code and Japanese Electrical Code specify detailed requirements for wiring methods and installation practices, including the methods for splicing wires, the methods for terminating wires at devices, the support and securing of cables, and the protection of wires from physical damage. It's essential to follow these requirements carefully to ensure that the electrical installation is safe and reliable. This includes properly torquing connections, using appropriate wire connectors, and protecting wires from abrasion and strain. Eighthly, inspection and testing. Before putting an electrical installation into service, it's essential to perform thorough inspection and testing to verify that it complies with all applicable codes and standards. This may include visual inspection of the wiring, testing of insulation resistance, testing of grounding continuity, and testing of overcurrent protection devices. In the United States, electrical inspections are typically performed by local building departments or independent inspection agencies. In Japan, electrical inspections are typically performed by licensed electrical inspectors. Ninthly, documentation and record keeping. It's essential to maintain accurate documentation and records of all electrical work, including wiring diagrams, equipment specifications, test results, and inspection reports. This documentation can be helpful for troubleshooting problems, performing maintenance, and ensuring compliance with codes and standards. In addition, it's important to keep records of any modifications or alterations made to the electrical system over time. Tenthly, continuous learning and professional development. The field of electrical engineering is constantly evolving, with new technologies, standards, and regulations being introduced on a regular basis. It's essential for electrical professionals to engage in continuous learning and professional development to stay up to date with the latest developments and maintain their competence. This may include attending training courses, reading technical publications, and participating in professional organizations. In conclusion, substituting Japanese wire for American wire gauge number 12 with thermoplastic high-heat nylon insulation requires a thorough understanding of electrical standards, regulations, and best practices. By considering ampacity, insulation temperature rating, voltage drop, grounding requirements, conduit and cable tray systems, overcurrent protection, wiring methods and installation practices, inspection and testing, documentation and record keeping, and continuous learning, it's possible to ensure that the electrical installation is safe, reliable, and compliant with all applicable requirements. Always consult with qualified electrical professionals to ensure that the work is performed correctly and in accordance with local codes and standards. Additionally, remember that codes and standards are constantly updated, so staying informed is critical for ensuring safety and compliance.